DNA. Okay. Now I'm going to add this guy right here. Do we know who he is? Rough ER. Okay. And I'm going to bracket him and bring him out. I'm going to put a number 2. I'm going to put ribosome 3 rough ER. Okay, now do y'all remember what ER stands for? Say yes or no.
Yes.
Okay, because if you don't, please say so. Endoplasmic reticulum. Okay, endoplasmic reticulum is nothing fancy or short. It's just a subway. That's all it is. It's for transport. Its job is to carry a material. All right? It is long. It's longer than the cell is. That's why it folds back and forth. Y'all see me do the brain before? Okay, and on Friday you're going to see me do that. It's all about folding for length, for saving space, for getting that in there. Okay, all right, now watch this. DNA is the blueprint, right? Okay, then RNA. There's this guy called RNA, and he lives up here, and he's called the nucleolus. Am I off? Yep. All over the place, right? The nucleolus has a guy called who? RNA. RNA is the cousin to DNA. Now, how's he different? He has only half a ladder, and his job is to go copy the DNA. All right, now let's just think about this, okay? All right. Katara? Where's your dream home? Where would you want to put it?
On probably 5 acres in the country somewhere.
In the country in Oklahoma? Oklahoma girl. All right, 5 acres, okay? She's going to build her dream home. Do you take the original blueprints that you paid $5,000 to get all made and worked up? Do you take those blueprints? Y'all leaving us already? Y'all just got here. Oh, okay. Oh, that was sweet. That was sweet. Yes. Okay. So, so what we're going to do is we're going to take your original blueprints and we're going to take them to the construction site, right? The ones you paid $5,000 for. You want them there at the construction site?
No.
You want your originals there?
No.
What do you want?
Copies.
Copy. That's right. Okay, so DNA is never allowed to leave the nucleus because it's valuable. It's the original blueprint. Okay, so if we're going to make anything by a cell, we're going to send a what? A copy. That's right. So RNA is going to go copy. Now, is it going to copy all of the DNA or is it just going to copy that section? So if we're laying the foundation for your house, do we take all of the blueprints or do we just take the blueprint for the foundation and plumbing? Okay, a section of DNA for that one protein is called a gene. That was it. So when we build our set of shelves, that option B is just a gene. So the RNA goes and copies what? Just that section. Calm down, I know it's exciting. Calm down, okay. So we're going to copy that section down. Then RNA is going to go take it over here to the ribosomes. What do ribosomes do? But what are they going to do? They make what? They're going to make the protein. They're going to read the RNA and they're going to what? They're going to make that protein. And once the protein is going to be made, who's going to carry it? Yeah, because if you're stuck on this subway right here on the outside of it, as soon as it makes it, it goes in the ER and transports it, right? All right, everybody good? Yes. So far, all right? Okay, good. All right, then watch what happens. We have this cool, looks like flat pancakes. I'm not sure why books always make them green. Okay? But this guy right here is going to be number 4. And number 4 is going to be the Golgi. Now, sometimes it's called a Golgi body, sometimes it's called a Golgi apparatus. Really makes no difference which one it is. Okay, but the Golgi is, just think of them this way. They're the UPS of the cell. So that tells us what? They're going to package and ship. That's right. They're going to take this protein, which is going to be transported by the ER to the Golgi, and then the Golgi is going to ship it out through this little tiny vacuole called the vesicle, and it may ship it where? Out of the cell, yeah. If it does that, y'all know that is exocytosis. That's right. Or it may use it in the cell to repair a mitochondria that's getting worn out. Does that make sense? Yeah. Or it might make nails. Your nails grow, yes. Your hair grows. If you get a cut, it heals, right? I love that, how we call it healing. It's all that's going on is this right here, either mitosis or protein synthesis. But the church stuck what word to it? Healing. Yeah, because we don't say a patient in a burn unit, oh my goodness, you're doing great mitosis. Excellent mitosis and protein synthesis. Look at that granulosa layer. That looks beautiful, right? We say you're what? Healing. Okay, so it's either one of two things. Either protein synthesis is going on or mitosis. Or both, right? Does that make sense? Okay, now watch how I taught it to you. I taught these organelles together because they work together. DNA, RNA, ribosome, RefER, Golgi. They work together to make proteins. Cool? Yeah. I know when I was a student, maybe y'all had the same experience. We learned the parts of the cell, and they were just like little pieces of paper. But I didn't get how they were tied together. All right? Okay. Cells are smart. They're very smart. They have intelligence. Okay? All right. Everybody go with that one? All right. Now, the rest of these, we're going to kind of boogie through. Yes?
Question on something I got confused on is with genes.
Uh-huh.
Obviously, you're saying there's any number of length of the nitrogenous base.
Yes. Some genes are longer, some are shorter.
ATCG. So how far is the range to make protein? I guess it depends on the simplicity of the protein.
Mm-hmm. Yeah, and remember, there's a lot of what we call junk DNA that's never read. It's never used. It's just in there. I know we haven't figured it out either, but it's there. Yeah, I know. So we've almost got. They say we have the genotype, the genome of the human done, but I still think we have a lot to discover about why that extra DNA is in there. So there's all kinds of hypotheses why.
That's where the
there.
superpowers are.
Oh yeah, sure. Now that sixth sense stuff. Yes. Okay. All right. Here we go. Is everybody okay with that? Uh huh. Oh.
It's about 1.
We can't bring. Oh.
They don't allow it.
Oh. They don't allow food in here.
I was gonna go get us pizza.
All right. We'll figure it out.
Okay.
All right. We'll figure it out. Okay. Here we go. Y'all got to get on page 1 before we break for lunch, or I'm just going to be sick. Okay. Here we go. All right. We know who this is, right? You all know who these guys are? Mighty mitochondria. That's right. All right, ready? All eukaryotic cells have it. Okay? The mighty mitochondria. Okay? These guys are the powerhouses. They make ATP. All cells have it. All eukaryotic cells have it. Every single one of them. Okay? Everybody good with that? Plant cell, fungi, protista, right across the board. Okay, now I'm going to give you a little history about them. They're very interesting. And the same thing is true about chloroplast, which you only find where? Not just plants. Protista, some protista have chloroplasts, like Lena's. They're producers. That's right. So organisms that can actually take sunlight, which we're going to talk a little bit more, hopefully before lunch, they can actually take sunlight and transfer it and trap it into molecules of glucose. Okay, everybody ready? Okay. So Chloroplasts and mitochondria have an interesting theory about them. Okay? And I always like to propose things as theory because I don't want to step on anybody's religious toes. Okay, but this is a biology scientific workshop. Okay? All right, ready? Back in the day, when the earth was forming, it was a little bit of a rough place to live. In fact, you couldn't live. It was loaded with methane, there was no oxygen, right? Okay. Theory. We were hit by meteors on a very kind of regular basis. And those meteors were made of ice. And that ice had organic materials in it. And what happens to ice when it hits heat? It melts, which help cool the earth and form pools of organic materials. Also put off water vapor in the air, which help cool. These organic pools, which were named organic soup, formed the first cells, which were prokaryotic. Everybody good? Okay. These prokaryotic cells were pretty much anaerobic. They were what we call, they were just anaerobic. They could not exist in the presence of oxygen. Okay, does that make sense? They're called an obligate anaerobe. Everybody good? Okay, so as millions of years transpired, of course you got to understand there's no UV protection. So the DNA that was randomly formed or brought in or whatever was easily mutated. Does that make sense? There was damage. So that means these cells changed quite a bit. Well, oxygen began to be made by some of these cells. Well, if you're an obligate anaerobe and oxygen is beginning to develop in the atmosphere, that's not good for you. So these little guys said, hey, if you let me come in here and live in here, I'll make energy for you. Cool? And that is the birth of the mitochondria and chloroplast. Chloroplast said, I'll make food for you if you let me come in. It's called the endosymbiotic theory. Endo meaning what? Inside. Come inside. Symbiotic means what? You give me a place to live, I'll make this for you, right? Everybody cool with that? It's a theory. Okay, I'm not saying it's a fact, but that's the gist. That's where, quote, chloroplast and mitochondria were thought to come from. Now, here's the neat thing about them. Chloroplast and mitochondria have their own DNA. And then neat? Okay, now you're thinking, what does that got to do with me? Well, let me show you, okay? All right, let me pick on Dawn. I haven't picked on Dawn here a little bit. Well, I have a little bit, but not enough. Okay, Dawn's sitting there, 10 o'clock at night. He's flipping through the commercials. And he comes across this cool infomercial. Well, it used to be P90X. Now we got Insanity, right? Okay. And he's like, I think I could do that. I could do it. So he orders it. He doesn't tell any of his friends about it because you don't want that kind of pressure, right? All right. So he begins to get his push-up bars, pull-up bars, and he begins to do he gets his bands, and he starts doing his P90X program. Now, when Don started, let's say a single muscle fiber in his bicep had 400 mitochondria per cell. Okay, because when you're a muscle cell, you work, you've got to have more than one. Everybody cool? Well, here's what's neat. The muscle cell, skeletal muscle, is in permanent growth arrested, right, everybody? It cannot do what? It can't do mitosis. But because his energy demand has gone up, the cell needs more energy. So how does the mitochondria accommodate that? It makes more of itself because it has its own DNA. So now by the end of the 90 days, okay, let's say you were pretty strict about it. Now most people take 6 months to do the 90-day workout. and that's okay because you really actually should skip a day in between or 2 days in between. They don't tell you that, okay? But if you really do the 90-day religiously and you're not in good shape, you could end up in the hospital, so you got to be careful. But the thing is let's say after 90 days, people notice it. Yeah, pants are slimmer, you get that V shape. Woo, look at you, Dawn, okay? And at a workshop, you got 3 women around you. Okay, anyway. But the thing is, what you're noticing is, he has more what? Energy. And his muscles are a little bit bigger, yes, and he's more shapely, but he has more what? That means that that cell now has 1,600 mitochondria per cell instead of 400. Now what happens if, he and his wife end up, she gets pregnant, and that's great, because he's doing P90X, okay? So, and then, okay, so, and then, woo, look out, they got twins. Okay, now when you have twins, you don't have time for what? P90X. Okay, so now his energy demands go down differently, right? He's not doing that, so now he goes from 1,600 down to 800. So your body adjusts the number of mitochondria per what? The energy demand. Okay, so you following me? Yeah, so that's what's really neat about mitochondria. It's the same thing for cells. Any kind of cell, the more energy they need, the more what? Mitochondria they can make. And we can find out who's related to who, not just by DNA, but by mitochondria DNA. Okay, which has surprised us in some instances. Okay, all right, here we go. This guy right here looks familiar, yes? It's an ER also. This is smooth ER. Now, when your hands get rough, what do you put on them? Fat, right? Oh, I gotta give me a squirt of fat. Okay. It's glycerin, isn't it? Yes, and it makes your hands really soft. Okay, so the way you can remember, smooth ER transports lipids, fats. Okay, and so now listen, your liver is loaded with smooth ER because guess what? It has to metabolize 24/7 fats. That's right. And if it has to stop what it's doing, because maybe this person had an accidental drunk. Okay, that happens as you get older. You don't mean to get drunk. See, in college, you actually set out to do that, which is not good either. Okay, but let's say you get to chatting with a friend and you normally only have 2 glasses of wine. Now you've been chatting so long that you actually had 6. Oops. Okay? And you're calling your hubby to go, I think you need to come get me. Okay, so what's happening is the liver has to stop what it's doing. And it has to do what to the alcohol? Yeah, it has to detox it. It changes it into a less poisonous substance. But it stops doing with its fat metabolism. Has to stop it. So it builds up in the liver, and what do they end up with? A Rice Krispie liver. Yeah, it looks like a Rice Krispie treat. Yeah. Think about that next time you eat one of those. Because it's exactly what it looks like. It's fluffy like that. But wait a minute. After we detox the alcohol and get it out, what's it do? Catches back up. Yeah. Okay, so some cells are going to have more of one type of organelle than another based on what? That's right. So you all learned this a long time ago. Structure determines what? Function, right? So that's what you're seeing here. That the certain amount of organelles in a cell is going to determine its function. So the structure determines its function. Now watch this. And then function is going to determine what? Location. So if I'm a cell that has lots and lots and lots of smooth ER, I'm going to be found where? In the liver. That's right. If I have lots and lots of contractile proteins in mitochondria, I'm going to be found where? In a muscle. See? So a cell, when we do this and you guys learned this generic cell, you didn't see how they didn't tie it all in to how the biology part of this works, okay? All right, a couple of other things here. Y'all remember vacuoles, right? Those are just storage, okay? Something that teachers don't do a lot of teaching are these little guys right here, which is the cytoskeleton. Thank you. Yeah, don't be shy. Just tell me.
You're amazing.
Yeah, you're way better teacher than I am.
Thank you very much. Thank you. I'm embarrassed. Cytoskeleton. Okay, y'all heard of it, right? Okay. Okay, the cytoskeleton is made of microtubes and microfilaments. It's, you know what it reminds me of? Do y'all remember that game when you were little pickup sticks? Remember how you pour them out on the floor? Remember that? Okay. Next time you do it, just do that for your class or something if you're teaching this. pour it out in your class and just look at it and go, look, that's a cytoskeleton. Yeah, okay. Now you can move it around. That's what white blood cells do. They constantly restructure their cytoskeleton so they can do the cytoplasmic streaming, okay? But other cells, boom, they're locked into that. Okay, now here's what a lot of teachers don't tie in, is that this cytoskeleton is tied in to proteins on the cell membrane. See it? That's what keeps them anchored in a spot. Okay? All right. So, cell membrane, what's its job?
Hold it in.
Yeah, okay. And it isolates outside from inside. The shape of the cell. Controls what goes
In and out.
in and out, right? We call it transport, right? Okay, now wait a minute. So now we're going to go to that transport that you were like, oh, no, okay, it's all right. Okay, ready? Let me flip this. All right, ready? I'm going to go to the back of my page. Okay? Here we go. I'm flipping back of my page here. Cell membrane. Also called the plasma membrane. I'm not sure your test will be that picky about that. Okay, here we go. See these little guys? Now see I have two tails? Okay, those are phospholipids. Phospholipids have two. Triglycerides have three, and they're a source of energy. Okay? Everybody good? Okay, now, do y'all remember their personalities at all? That's right, very good. Okay, so maybe looking at my head like personalities. Okay, I love atoms. They are so funny to me because you have to belong to a club if you're an atom, right? Y'all know the clubs, they're called elements, right? If you have a certain amount of protons, then you belong to this club. For example, if you're hydrogen, you only have one proton, you belong to hydrogen. Cool? If you have 8 protons, you belong to the club oxygen. That make sense? Okay. So, I know y'all know that as atomic numbers. All right, okay. But it's a club, isn't it? Okay. They have personalities. Y'all know that, right? Okay, so when atoms get together and make a molecule, they really have a personality. So for example, this head up here, now by the way, those of you, if you end up teaching some of this, this is in my module 1, so if this helps you, this is in module 1 of the STAR notes, okay? So if you end up teaching it, it's there. Okay, first of all, this is glycerin. Okay, known as glycerol, and it is hydrophilic. It loves water, okay? And that's because it has a personality called polar covalent. Okay, now do you kind of remember bonding at all? Okay, I love those looks, Charlotte. Watch this. Real quick, we're going to take a little side detour over here to the side. Okay, y'all ready? Y'all remember sodium? Okay, sodium has 11 protons. Now remember, protons are positive, right? If you have 11 positives, you have to have what? 11 negatives, so electrons. Okay? So you don't have a charge at all, right? Okay, does everybody feel good about that? Okay, do y'all remember how to fill shells? Don't get scared. Yeah, don't do it. It's easy. Just remember 2, 8. You remember that? 2 and 8. That's it. You're looking at me like I had chemistry. I don't remember that. It's easy. The first shell can only hold what? 2. Okay. So there's 2 electrons in the first shell. It's the smallest, so it can only hold 2. Okay. The second shell can only hold what? 8. All right. Very good. Now that 2 plus 8 is what? 10. Tough in here, isn't it? Okay. Ready? Which means now our magic number is 11. How many electrons do we have? We just have 1 left. But I can hold how many? What's the magic number? 8. See, from now on it's going to be what? 2 and 8. You're going, wait a minute though, the third shell has 32. Yeah, 32 divided by 8 is 4. That means it has 4 subshells all filled with 8. Yay! See, chemistry was a lot easier than they made it out to be. Okay, here we go. So we have 1 electron. Y'all see that 1 out there? Oh. Sodium. Not happy. Because he doesn't want 1 electron. It's like when you invite a party. You really like to have even numbers, don't you? It's odd if you have that one person who just got divorced. You want to invite them, but you know what I mean? Because they're, yeah, it's hard. Okay, all right, so same thing.